Physical Science, Chapter 8, Energy Sources and the Environment. The big idea for the chapter is energy can be transformed from one form to another for human use. So suppose you're the first one on the school bus in the morning, and after a few more stops you notice that the bus is rather noisy. By the time you get to school, every seat on the bus is taken. Like space on the school bus, space on Earth is limited. And throughout this chapter, you will see us modeling population density on Earth. Section 1 is all about fossil fuels and your essential questions. Which energy resources do you use daily? What is the law of conservation of energy? How do fossil fuels form? How is the chemical potential energy stored in fossil fuels converted into electrical energy? So you can see energy being used in many ways throughout the day, such as those shown below. Furnaces and stoves use thermal energy to heat buildings and to cook food, respectively. Air conditioners use electrical energy to cool homes. Cars and other vehicles use mechanical energy to transport people and materials from one area to another. In 1 hour of driving, a car might use 2 or 3 gallons of gasoline. It might be hard to believe that it took millions of years to make the fuels that are used to power your car, to produce electricity, and to heat your home. Coal, natural gas, and petroleum, also called crude oil, are fossil fuels because they form from the remains of ancient plants and animals that were buried and altered over millions of years ago. And if you remember back when we were talking about the Oligaga, aquifer, and it was fossil water because it was millions of years old. Same concept. The fuel with the greatest chemical potential energy per gram releases the greatest amount of energy. And as you can see, natural gas, petroleum, coal, and then wood. Millions of liters of petroleum, a fossil fuel, are pumped from wells within Earth's crust every day. Petroleum is flammable. It's a flammable liquid formed from the decay of ancient organisms such as microscopic plankton and algae. It is a mixture of thousands of chemical compounds, and most of those compounds are hydrocarbons, which means that their molecules are made of different arrangements of carbon and hydrogen atoms. Petroleum, also known as petroleum jelly, Vaseline, is blended with paraffin wax to make medicines, moisturizers, and other toiletries that you might find in a bathroom cabinet. And here is an example of that. It's also found in a lot of cosmetics and skincare. Interesting fact, before they figured out how to refine it and be able to market it and sell it to people safely, it used to be considered a waste product. They used to just literally dump it. And so this was the waste left over after they got done refining the petroleum and the oil for cars and diesel machines. And they said, oh, hey, I think we can use this for something. Same thing with plastics.
Oil is formed deep in the ground from the effects of long-term heat and pressure on ancient plant and animal remains. The oil is either pumped to the surface or rises to the surface under its own pressure. This crude oil is a mixture of many different hydrocarbons. It is shipped to the refinery by tanker or pumped locally by pipe. These hydrocarbons are separated using a process called fractional distillation. The crude oil is heated in a furnace and fed into a large heated tower. The tower consists of many levels where repeated condensation and vaporization occurs as the hydrocarbons rise through the tower. Because boiling point increases with molecular weight, lighter fractions will move further up the column while heavier fractions remain near the bottom. The repeated condensation and vaporization increases the purity of the fractions found at each level. These fractions are piped off to other locations around the plant for further purification and distribution. Many hydrocarbon products are produced at the refinery. The chief products include alcohols such as the solvent methanol, liquefied petroleum gas used in gas grills and for heating homes, gasoline, jet fuel, kerosene, heating oil, diesel fuel, light and heavy lubricating oils, petroleum jelly, greases, and asphalt, which is mixed with gravel to make road surfaces.
The chemical processes that produced petroleum when ancient organisms decayed and were buried on the seafloor also formed natural gas. Due to differences in density, lightweight natural gas compounds are found trapped on top of petroleum deposits. Natural gas is a fossil fuel composed mostly of methane, but it also contains other gaseous hydrocarbon compounds such as propane and butane. Coal is a solid fossil fuel that can be found in mines, such as the one shown here. During the first half of the 20th century, most houses in the United States were heated by the combustion of coal, and many of the homes in Leadwood, you can still see the trap door on the basements and crawl spaces where the coal would be delivered to. In fact, during this time, coal provided more than half of the energy used in the United States. Now, almost 2/3 of the energy used comes from petroleum and natural gas, and only about 1/4 comes from coal. About 90% of all coal that is used in the United States is burned by power plants to produce electricity. Fuel burned in a boiler or combustion chamber converts chemical potential energy into thermal energy, which heats water and produces pressurized steam. This steam strikes the blades of a turbine, causing it to spin, converting thermal energy into mechanical energy. The shaft of the turbine connects to an electrical generator, which converts mechanical energy into electrical energy. The electrical energy is then transmitted to homes, schools, businesses through power lines. And if you remember when we were talking about thermal energy turning into mechanical energy, and it was the engine in the car with the pistons going up and down, turning the drive shaft, this is the same exact concept. So if you love cars, pistons, that's all you need to know. So here we have an example of a power plant that efficiently describes how much energy is available to do work and to produce energy. In the first stage, the chemical potential energy is stored in fossil fuels right here, and it is converted into thermal energy as the fuel is burned in a boiler. Okay? And then, interesting fact, only about 60% of the available chemical potential energy is actually converted into thermal energy. So here we have the thermal energy, and it heats water and it produces steam. This stage is only about 90% efficient, which is a little bit better than stage 1. Stage 3, you have the pressurized steam comes through here down into this turbine which spins the blades, and then thermal energy is converted into mechanical energy. This stage is 75% efficient. Although fossil fuels are common energy source resources, their uses have undesirable effects. Burning fossil fuels releases small particulates into the atmosphere that can cause breathing problems. Fossil fuels also release carbon dioxide when they're burned. The figure below shows how the CO2 concentration in the atmosphere has increased from 1958 to 2010. Many scientists think this increase in the atmospheric CO2 concentration has contributed to global warming. Now, this book is always saying global warming. We are always under global warming. That's why we're a planet. That's why we can live here. I think to make this more accurate from a scientific standpoint, it needs to say contributed to the increased effects of global warming. Because they are non-renewable resources, fossil fuels are decreasing in supply. As supplies of fossil fuels run out, fossil fuels will become more difficult to obtain, just like our ancient water systems and our aquifers. This will cause fuel prices to become more costly than they are today. Even as fossil fuel supplies decrease, the demand for energy continues to increase. Look at all the phones, the tablets, the computers. Everything that we have now, the beats, everything requires being charged somewhere. Well, that charge comes from this, non-renewable resources. Scientists have discovered numerous oil shale reserves in the United States, as shown on the next screen. When oil shale is heated to extremely high temperatures, it releases an organic chemical compound called kerogen. Kerogen is a petroleum-like substance that has potential for meeting increasing energy demands as fossil fuel resources are consumed. But remember, ladies and gentlemen, this is still a fossil fuel. It is still non-renewable in our lifetime. So this is the picture it was talking about. And we have oil shale deposits here in just right on the border, mostly in Indiana, and then going down to Kentucky. We have down here in Texas, so a few places. Your biggest concentration is on the East Coast. As population increases and fossil fuel resources decrease, scientists will always be searching for new solutions to the energy crisis. Energy alternatives such as oil shale deposits will help meet those demands.